All right, let's take another look at graphing and independent versus dependent variables. So remember, when we are graphing functions, we are going to fill out the table on our own. So if my equation is y equals 4x, I can pick any 3 input values. You could pick 100 if you wanted to, but I'm going to pick small numbers because it's easier to calculate. So I'm going to do 0, 1, and 2. So in this first one, I'm plugging in y equals 4 times our x value of 0. 4 times 0 is 0. So our output is 0. So the ordered pair is 0, 0. All right, for for input of 1, I'm plugging in y equals 4 times our x value of 1. 4 times 1 is 4. So our output is 4. So input of 1, output of 4. And then 2, y equals 4 times our input of 2. 4 times 2 is 8. So our output is 8. So the ordered pair is 2, 8. So let's go ahead and graph these points. 0, 0 is right at the origin. 1, 4 means 1 to the right, 4 up. 2, 8 means 2 to the right, 8 up. And if you have a dot, like if I had a dot over here, that doesn't form a straight line. So you want to make sure that when you are attaching it, it forms a straight line. If not, you did one of them or more than one of them wrong. So I draw my line, connecting them, draw my arrow on the end to show that it keeps going. Let's do one more graphing one. This time y equals 6x plus 4. Again, I'm going to plug in 0, 1, and 2. So y equals 6 times our x value of 0 plus 4. 6 times 0 is 0 plus 4. 0 plus 4 is 4. So our ordered pair is 0, 4. Plugging in 1. We're doing y equals 6 times our input of 1 plus 4. 6 times 1 is 6 plus 4. 6 plus 4 is 10. So our output is 10. Input of 1, output of 10. And last one, plugging in 2. Y equals 6 times our input of 2 plus 4. 6 times 2 is 12. Bring down the plus 4. 12 plus 4 is 16. So our output is 16. So ordered pair, 2, 16. All right, looking here, we got 0, 4. 1, 10 means 1 to the right, 10 up. 2, 16 means 2 to the right, 16 up. Again, it should form a straight line. If it doesn't, you did something wrong. And then we're going to go ahead and connect these. So that's a little refresher on graphing. Now let's look at independent versus dependent variables. So this chart on the top should be helpful. So remembering that the independent variable represents the x variable versus the dependent is the y. And then key parts here. Time is independent. So these are keywords: hours, minutes, months, days, nights, weeks, years, seconds. Versus for the dependent variable, money and totals are often dependent. So pay, spend, dollar, sell, buy, earn, or just the dollar sign would be key things that clue you to the dependent variable. So let's look at example 3. It says the Field Museum costs $8 per person to visit. Write an equation to find the total cost. So I'm going to go through these steps. Is there time in the problem? Do I see anything about hours, minutes, months, days, nights, weeks, years? No. So next question I'm going to ask myself is there money or totals in the problem? Yes, I see $8. So I'm remembering my independent represents X, my dependent represents Y. So when I'm looking at my dependent variable, we know it's money. The Field Museum costs $8 per person to visit. So we could say money spent, right? Because people are spending money to go to the Field Museum. Well, what are they spending money on? It's per person or per ticket if you wanted to say that. But since the word that I see in here is person, I'm going to say number of people. So the money that's spent depends on the number of people that attend. Number 4, Katie is driving at a speed of 55 miles per hour. Write an equation to represent the total distance traveled. So it says, is there time in the problem? Yes, I see specifically the word hour. Hour refers to time. So our time is always independent, our X variable. So we're talking about hours, so I'm going to say the number of hours. Then I'm still going to ask myself, is there money or totals in the problem? I don't see any money. It does say total distance, which should be a clue, okay? But I don't specifically see money. Maybe you could say totals. Why don't we say totals? Sure, because it's talking about total distance. And specifically, we're talking about miles. So the number of miles. And then last one, Sheldon is building a comic book collection. He plans to get 10 comics each week. So is there time in the problem? Yes, it specifically says weeks. Weeks is a form of time. So remembering independent is X, dependent is Y. So we're saying that our time, the number of weeks, is an independent variable here. Well, what are we talking about each week? What is he doing or collecting each week? The other unit we're talking about here is the comics. So the number of comics, and specifically I'm going to say collected each week. And that's it.